All right, let's get right into it. If you're building anything with retrieval augmented generation, RAG, there's one single piece of the puzzle that is an absolute make or break for your entire system, and that's chunking. Getting this right is, seriously, everything.
So why is this one little step so critical? Well, you've probably been there, right? You feed your AI a ton of documents, you ask what seems like a simple question, and you get back an answer that's just complete nonsense. The thing is, the problem usually isn't the model. It's how you broke up that source text to begin with.
At its heart, chunking is really just that, splitting big documents into smaller, meaningful bits. See, large language models have a fixed attention span. It's called a context limit, measured in tokens. And while these limits are getting bigger, from 4,000 to even over 200,000 tokens, your documents are almost always way longer. So the real trick is splitting them without completely destroying the meaning.
And this is the chain reaction of failure, the domino effect that we're trying to avoid. You start with bad chunking, which means you lose context. When the context is gone, the AI can't find the right piece of information. That's poor retrieval. And when it grabs the wrong info, you get wrong answers. It all starts with how you split your text.
Okay, so where do we start? Well, we start with the most common, the most straightforward method out there, fixed size chunking. Just think of this as the first tool you've got to master. It's the foundation for pretty much everything else.
The logic here couldn't be simpler. It's totally mechanical. You just define two numbers, a chunk size, let's say 500 tokens, and an overlap, maybe 50 tokens. Then the algorithm just marches through the text and, snip, cuts it at those fixed points. That's it. But here's the trade-off, and this is super important. On the one hand, yeah, it's fast, it's simple, and it works on literally any text you throw at it. But on the other hand, it's a blunt instrument. It has zero understanding of grammar or structure. It'll happily chop a sentence right in half, split a key idea across two chunks, or even break a piece of code, making it totally useless. So the problems with fixed-size chunking naturally lead us to the next level, intelligence splitting. Now we're moving away from just counting tokens and getting into methods that actually try to understand the meaning and the structure of the document itself. And this is where things get really, really powerful. The key difference here really comes down to the goal. See, fixed size is all about uniform size. Semantic chunking, on the other hand, is all about coherent meaning. It uses something called sentence embeddings, which is just a fancy way of turning sentences into numbers to spot the natural breakpoints where one topic ends and another one begins. The result? Each chunk is a self-contained, logical piece of information. And it doesn't even stop there. Other intelligent strategies take this even further. You've got structure-aware chunking, which uses the document's own formatting, like chapters and headings as the cutting points. And then there's content-specific chunking, which is even smarter. It knows to chunk code by functions, not by lines, and to keep tables whole. Okay, so now that we have these much more powerful strategies, let's talk about fine-tuning. We're going to look at a specialized technique and then dive into one of the most crucial settings you need to understand, overlap.
The sliding window method is an amazing tool for those times when you absolutely cannot afford to miss a single piece of information. By creating these heavily overlapping chunks, it basically guarantees that any fact, no matter how small, is fully contained inside at least one chunk, even if it happens to fall right on a boundary.
This visual makes the idea of overlap perfectly clear. Just think of it like a safety net. The end of chunk 1 is repeated at the start of chunk 2. This makes sure that a complete thought that might have gotten split across the original cutoff point is still preserved and can be retrieved as one whole idea. So the big question, how much overlap should you actually use? Well, 10% is pretty minimal. 50% will give you incredible recall, but it's going to cost you more in storage and processing time. So here's the key takeaway. A 20% overlap is the sweet spot. It's the balanced recommended starting point for most projects. Phew, we have covered a lot of ground. So let's bring it all together. Let's build a practical framework that you can use right now to choose the right strategy for your specific project. This table right here, this is your cheat sheet. Seriously, if you're working with straightforward stuff like articles or reports, just start with fixed size. For long, dense essays with clear topic shifts, semantic is absolutely the way to go. Got a well-structured manual with chapters? Use structure-aware. And for anything specialized like code or markdown, you'll want a content-specific approach. And here is your process for tuning. Don't overcomplicate it. Start simple. Go with a standard fixed-size approach, 500 tokens, 20% overlap. Then, test it. Run some real-world queries against it and see how it does. If the quality just isn't there, then you can upgrade to a more intelligent strategy. Always let data, not what you think might work, guide your decisions. This really is the core philosophy. Your chunking strategy isn't just some minor detail you can ignore. It is the single biggest factor that will determine the quality of your RAG system. So start with the simplest tool that could possibly work, measure its performance, and only add complexity when the data proves you actually need it.
So there you have it. You've got the framework, from the simple to the sophisticated. You understand the tools, you get the trade-offs, and you have a data-driven process for tuning your system. Honestly, the foundation for a super high-quality RAG system is now in your hands. The only question left is, which strategy are you going to test first?